In a previous session, I showed you how to partition a line segment on a number line. In this session, I'm going to extend that concept and show you how to partition a line segment on an XY coordinate plane. In this case, we have this line segment AB, which has coordinates -2, 3, and B is 8, 12. We want to find point P on this directed line segment AB such that the ratio of A to P, that is from A to some point P, is in the ratio of 2 to 3. So A to P and P to B is 2 to 3. So A to P is 2 of 5 pieces and P to B is 3 of 5 pieces. Now, when we partitioned the number line segment, what we did was we divided it into a number of equal pieces. Well, in this case, we have a diagonal segment. So what we're going to do for the sake of ease of use is we're going to break this diagonal segment into a horizontal component and a vertical component. So let's bring those in. So now we have this line segment is equal to this component plus this component. And if we partition this component and then partition this component, we will be able to find out where the point on this exists. So let's just start from the beginning because that may be a little confusing at first. So what I'm going to do is I'm going to break the horizontal piece into 5 more or less equal segments. So let's put one here, and one here, and one here, and one here. It doesn't have to be perfect, just 5 relatively equal segments. We're going to do the same thing with our vertical piece. So let's just put one here, and one here, one here, and one here. Okay, close enough. Now, our point P is going to exist where somewhere on this segment where the partition of this and the partition of this intersect. So we need 2 of 5 pieces. So we're going to use this number in this case. So let's go ahead and find out where that would be. So going from A to B, we're going to go in this direction to the upper right. So we're going to move to the right horizontally. And we have to move to the right 2 units. Well, here's 1 unit, 2 units. So the horizontal component of point P is going to be somewhere in that vicinity. Now we want the vertical component of point P. So since we're going from A to B, we're going to start at the y coordinate of A, which is this line here, and we're going to go up. So from here we go up 2 units, 1, 2. So this is where the vertical component of point P is. Now where these two, if we extend lines through these points, a vertical line and a horizontal line, we'll find out approximately where these two intersect, and that's going to be approximately where our point P is. So close enough. So this will be the approximate location of our point P. So now what's left is we have to find the length of each one of these pieces here and then the length of each one of these pieces. Now the reason we're doing that is because we're going to count over from this x coordinate this distance, and we're going to count up from this y coordinate this distance. So we need to know these individual distances. Well, just like we did in the other video, we're going to find the entire length of this horizontal component, and we're going to divide it by the number of pieces that we have, and that'll give us the length of each piece. So we use the ruler postulate. So the ruler postulate says the absolute value of the difference of the coordinates. In this case, we're going to use the x coordinates. So it's -2 and 8. So -2 minus 8. -2 minus 8 is -10, and the absolute value of that is 10. All right. So we have a length of 10, and we're going to divide it by 5 total pieces. That's 2 on the left, 3 on the right. So 10 divided by 5 gives us 2. So what that means is each one of these pieces is 2 units long. So let's just put a 2 in here and a 2 in here. Now we're going to do the same exact thing for the vertical piece. So we take the y coordinates in this case, and it doesn't matter whether you use this one or this one first. So it's the absolute value of 3 minus 12. 3 minus 12 is 9, and so that's actually negative 9, and negative 9 absolute value is just 9. So now we divide that 9 by 5 equal pieces. So 9 divided by 5, 9/5, since that doesn't reduce. So each one of these pieces is 9/5 long. So since this is 9/5 and this is 9/5, now that's all we have to do is find the coordinate of this point and the coordinate of this point, and those combined will be the coordinates of our point P. So let's start with the x. We're going from A to B in this direction, so we start at that x coordinate. So the x component of our point P is going to start at -2, and we're going to the right, so we're going to add, and we're going to add this much. So we're going to add 2, and then we're going to add this much. Add another 2. So basically we're just adding 2 pieces. So this gives us -2 plus 2 is 0 plus 2 is 2. Now we're going to do the y component of point P. Oops. Okay. Now we're going to start at the y coordinate of our starting point. We're starting from point A because we're going from A to B. So the y coordinate is 3. And from 3, we're going up. And we're going up 2 units of 9/5 each. So we're adding 9/5 plus 9/5. That is 3 plus 9/5 plus 9/5. Well, we got to find out how many fifths are in 3. So we're going to take 3 and we're going to multiply that by 5 over 5. And since 3 is 3 over 1, 3 times 5 is 15, and 5 times 1 is 5. So 3 is the equivalent of 15/5. So we have 15/5 plus 9/5 plus 9/5, which comes out to 34/5. So we now have our coordinate of point P. Our x for point P is 2, and our y is 34/5. Granted, it's an ugly number, but at least if we can do an ugly one, we should be able to do a fairly clean one at any point in time. I hope that worked for you. If not, I will put another tutorial session and we'll try again.